Basically what this looks like is stuff like this. We are no longer just taking regular boring square roots or cube roots. We are taking nth roots. All right, what this means is basically when I'm looking at something that says, what is the fourth root of 81? What that is asking you is, what is the number that I can multiply by itself 4 times to get 81? Just like when you had the square root of 16, what are 2 numbers you multiply together that get you 16? Well, 4 and 4. In this case, it's asking you, what are 4 numbers? What is a number you multiply 4 times to equal 81? It's 3. Okay, this one's relatively simple. What's nice here is that there's a button in your calculator for finding some of these nth roots. If you look on your calculator, if you hit the button that says math, there's a button that says, there's an option that says x root, I believe. If you hit that x root button, it'll allow you to change your the exponent in front of it, the nth root, if you will. Right now, if you press that x root button, it probably says answer root. Usually what happens, you just have to go back and overwrite it, unless you put in, let's say you want to do the 4th root right away. For example, here, let me clear this out. If I go to my math, then it says x root for option 5. It says answer. Just go to the right, and you can just overwrite it and just say 4, and it'll change it, bring it back in. You take the 4th root 81 right there in the calculator button. Okay. Or if you set it up the other way, if you hit 4 math of x root, it changes it to that exponent right away. It's 2 different ways to type that in your calculator if you had to find the 4th root of 81. Again, when we get into this test, as I start to show you guys some of these rules and stuff like that, as far as how the nth roots and stuff work, there will be a part where you'll have to simplify some of these nth roots by hand. We'll have calculator, non-calculator again with this as well. Remember, this is the first time you've seen it. I don't expect you to know the 4th root of 81 right off the top of your head. But as we get into this, I'm expecting you guys to know a little bit of these things. Okay? All right. So let's continue. A couple of the rules that happen here are real simple. It makes a lot of sense when you start to say this instead of reading what it says in terms of the lettering here. Basically what this is saying, if your nth root is an odd number, 1, 3, 5, 7, or whatever, you basically have one real root of A. Example again, if you have the cube root of 27, how many answers are you going to get? 1. It's not like taking the square root where you can have a plus minus. If you take the cube root of 27, your n value is odd, it's 3. Your a value is a positive number, 27. This is giving you the fact that the cube root of 27 is, well, what are 3 numbers you multiply together that are the same to get 27? And we should know this one, right? It's 3. So what this is telling us is that if it's an odd number and a is greater than 0, you're going to have one real answer. If it's an even root, if it's the 4th root of a number, if it's the 4th root, that means what are 4 numbers you can multiply together that are the same to get you to 81? Well, a little while ago we said it was just 3. It's 3 and negative 3. That would be a plus minus. So basically what you need to remember here is if your nth root is an even number, you have to put plus minus in there. If it's an odd number, it's whatever the answer is. Okay? Remember, you can take odd roots. If this was the cube root of negative 27, your answer would be negative 3. You can take odd roots and get a real answer, and that's okay. Even roots, you wind up with an imaginary answer. Yes, sir?
If you had an odd number root and the answer inside would be negative, would your answer
Yes. Yes, and let me show you that. Again, with something very simple of one that we should probably know off the top of our head. If I take the cube root of negative 8, that means what are three numbers you multiply together that are the same to get you to negative 8? It's negative 2. Because if you look at that, that's the same as saying negative 2 times negative 2 times negative 2. Well, see how you have odd number of signs? Odd number of negative signs, I should say? That gives you a negative result. So you can take an nth root that is odd of a negative root, I don't know what to call it, of the radicand, or whatever it's called. The number underneath the radical sign. Bless you. Okay? So that is possible. Again, if it's an even nth root, and it's a negative on the inside, you're not going to get a real answer. It's going to be an imaginary answer. And I don't, in this chapter, we don't really deal a whole lot with imaginary stuff. It'll come up a little bit later when we get to this solving equations. So again, when I'm looking at something like this, what you need to remember is the generic setup. For nth roots, it means this. For all of your nth roots, that's basically what these things work out to be. When you take the square root of a to some nth root, move this down a little bit here. It is a fractional exponent. That value of the nth root is a fraction exponent. I don't know if we discussed this a lot last chapter. We talked about square roots, but I think I asked you guys when we did it a few times, when you take a square root, did I mention that it was putting something to the half power? Thought I did. So if I take the cube root, it's putting something to the third power. So you can actually type that in your calculator as well. If I want to take the cube root of 8, I can take 8 to the 1/3, and it'll still spit out 2. So in this case, what they're asking you to do here is just find the real roots of what that is. If their value of a is negative 125, that goes underneath the symbol. What are three numbers you multiply together that are the same to get you negative 125? Negative 5. Good. That's all that means. You're taking it from the a's and the n's, and you're substituting it into the generic form. Remember, we write it over here as well. The nth root of a is the same thing as saying a to the 1 over n. Those are synonymous. Excuse me. Fourth root of 16. Plus or minus 2. Remember, because it's a fourth root, so it's an odd, or excuse me, it's an even value. Okay? Not so scary to start with? See, you guys are all on tryptophan still. Hope that you enjoyed your break. Maybe? I agree. Now the fun part. It's when you start mixing them together. It's not that bad. So the other part that comes into play here is you can have fractional exponents. And when you have fractional exponents, a to the m over n, remember, the n value is the nth root. That m value would be the nth root squared or cubed or whatever. What this means is the nth root of a raised to that. Always remember that the denominator of the fraction is always the nth root. The numerator is always on the outside. Okay? You look about that. And the same rules apply if it's negative. It's not happy where it is, so you just send everything down below and you follow through like that. So in this first example, 9 to the 3 halves. 9 to the 3 halves means the same thing as, well, the second root of 9 cubed. And the second root means what? Square root. Bless you. So what's the square root of 9? 3. What's 3 cubed?
27.
Here you go. When you're doing the fractional exponents, no. You don't have to worry. Okay. When I have 32 to the negative 2/5, that means it's not happy where it is. So it becomes 1 over 32 to the 2/5. Now the exponent is happy. Now the exponent is happy. So then you use the same rules. This becomes the 1 over the 5th root of 32 squared. Now, 32 is not that big of a number, is it? To have 5 numbers that are exactly the same to multiply together to get to 32, what do you think it might be? 2. 2 times 2, 4 times 2, 8 times 2, 16 times 2, 32. All right? So you get 1 over 2 squared, otherwise known as 1/4. Okay? Not horribly frightening? Let's go the other way. Well, we'll rewrite this in a second. This is saying the cube root of negative 8 to the 5th power. Well, I have an odd nth root. So can I take the odd root of a negative? Yeah. So what's the cube root of negative 8? Negative 2. So then what's negative 2 to the 5th power? Negative 32. Very good. Again, same rules apply. Since it's a negative value and I'm going to an odd exponent, I'm going to wind up with a negative answer. If it was negative 2 to the 6th power, it would have been a positive answer. Okay? Again, hopefully not so scary. But let's say I wanted to write this in terms of a fractional exponent. If I wanted to write the cube root of negative 8 to the 5th power, what would be my fractional exponent? It's your a value always stays as what this is. Oh, I thought you said 2. I'm sorry. And what does it go to? Is it the 3/5 or 5/3? 5/3. The nth root is always the denominator, and the power is always the numerator. That's how you would rewrite that out. So you might have to go either direction sometimes, just so you understand what it looks like. Okay? Those are heavy. I do. All right, let's look at another. We just did that one. All right, look at this. Look at number 5. It says the negative of 49 to the half power. Well, what does half power mean, guys? Square root. What's the square root of 49? So you just want the negative value of that. 7. Because it wants just the negative. Right. And then again,
Would it just be 7?
it's negative 7. And in here, we just did this one. What does that mean? 3,125 to the 2/5. Yeah, that's right. The 5th root 3125 squared. Now, if you look at that, you just took a wild and crazy guess. What do you think the answer is? I'm saying 25. That would be the answer, because you're right. The fifth root of that is probably 5. So 5 squared is 25. Is it right? Yes?
Yeah. Yes.
Sometimes you can sit there and look at the values and go, oh, wait, I need 5 numbers that multiply together to get this. If I'm ending in a 5, what do you think it's got to be? There will be some of these things you should be able to pick off the top of your head, even though it looks scary. Yeah. Well, no, I'm sorry. The fifth root of that was 5. 5 squared was 25. That's what I did. Because if you start thinking about like the size of numbers, if you're multiplying 25 5 times, 25 and 25 right away gets you 625. If you multiply that again by 25, it's going to be already bigger than the 3125. So you start playing around with the values in your head, try to see, okay, what could this possibly be? That's a good question. Okay. And the scariest parts of them all. Solve an equation with nth roots. And I don't mean to say that this is going to be horribly scary, but again, when you start worrying about how this stuff works, you have to still use your same old boring order of operations. You still have to go through how things are set up. You have to move everything off from one side prior to taking an nth root. So in that first example of 2x to the 4th equals 162,
Plus or minus 2.
well, what do you have to do first?
Well, you have to divide it by 2.
Divide out the 2. So you have x to the 4th of 81. And you're right. How do you undo the 4th power? You 4th root it. Okay? You're 4th rooting. Now, think about what that means. If you're taking the 4th root of x to the 4th, that means your exponent would be x to the 4 over 4, which is x. It's x to the 1. You're negating, I wouldn't say negating, you're simplifying out the powers to get you a first degree value of your variable. And again, in this case, you take the 4th root over an equal sign. What do you have to make sure you put? Plus or minus. If it was a 3rd root, did I have to do plus or minus? I only have to worry about plus minuses when I have what kind of a root? Good. All right. Jump cubed. Take the cube root of both sides. Good. What's the cube root of jump cubed? Jump. I don't know about you, but I can't simplify the cube root of 10. So what do? Call it a day. No. All you do is move 2. And again, if you have a root that you can't simplify, just tack that on the back part of it. Put your integer in front. It's math etiquette to go that route. Yes, sir.
If it was the 4th root, like jump to the 4th power, would you put x equals 2 plus or minus?
Yeah. Yep. Very good. Very good. Everybody hear what he was saying? If it was an even power, again, if you take an even root over both sides, you have to do plus minus. If it's an odd root, you don't have to worry about that. Yes, ma'am. No, because that's jump cubed. That means it's jump times jump times jump. You can't distribute that. Can't do that. Yes. No, because then you can have an odd root of a negative value. You just leave it as the negative 10 because that's inside the radical. So you just leave it it's in front of it. Try those real quick. Excuse me. Like I said, there's really not a ton of craziness involved in this first couple. What'd you get for the first one? Do we all agree? What'd you get for the second one? So you have, are you guys getting, is it -1? What do you get for the next one? 4, okay. And the last one? Plus minus. Remember, anytime you take an even root, guys, I'm sure that has absolutely everything to do with class revenue.
Oh, does it? It's skyward.
Oh. No. Worry about that when we get a little time here. Like I said, there's not that much in here you could. Children, I swear. Do you not need to go through any of those? Because towards the end of this chapter, it'll start to look like this. It'll look like something like that towards the end of the chapter. Baby, well, this is right. These are baby steps, so we're getting there. But we'll get to something like that eventually. Let's see. It's pretty straightforward. They give you some problems to work on. Like I said, I didn't have all that much involved with there's not that much in this first section. Just to get your feet wet about how to rewrite with the exponents. All right, so this is 71404. Give those a shot. On some of those first ones, where it says evaluate expressions starting at about number 30, they're asking you to do that without a calculator. I'm going to take in my heart of hearts that you will do that without a calculator, because on a test and or a quiz, that would be the complexity of some of these things I would ask you to be able to do without a calculator. There's some tape on the desk if you need it. Yes. It tells you in the book. It's like, I think it's number 30 through 40 of the evens in those sections. It says try to use those without a calculator. So like the cube root of -1000. What are 3 numbers you multiply together to get -1000? -10. Remember, what it's asking you to do is you're going